Hello friends, welcome to my channel Tech Buddy. So in this we will be solving various interview related questions, and also I'll be trying to help you in solving various HackerRank platform questions. So without wasting any time, so let's start. So here we will start with a very basic category of data structures, that's the linked list. So we will start with this question: inserting a node at the head of the linked list. So I will just explain what a linked list is. So linked list is a type of data structure where we store data uh, on demand. So linked list is implementation of the list interface, and it provides storing the data in links. So we will understand what is that. So here, so let's say now I want to store some data. So it may be duplicate, it may be unique, but I don't know at the beginning that how many data I have. So that's why instead of creating a array list, you may choose to create a linked list. So in this way, the advantage can be maybe when you are creating an array list, you are wasting a lot of space. Let's say you created an array list and the initial size is like 30 or 40. So you are wasting 40 blocks of memory. But instead, but let's say if you are just storing two elements, so it is a wastage of 38 blocks. So you can avoid that using the linked list. And there are also other advantages of linked list. We will discuss that later. If you want a detailed video about linked list, you can comment in the comment section. So I'll create a video about linked list. So linked list, how it stores data is it has two parts. So you have a structure of data. So it's, you can call this as a node where it has two parts. So one part is called the data. So here we are storing some data. So let's say we are storing 10 here, and the next part what it will do, so it will store the memory location or the address of the next node. So because when we are creating the linked list, we are not really allocating memory for storing the elements. That's why we need a pointer here which will tell us the address of the next node. So let's create another block here. So now we have a linked list with two nodes. Let's call this as A and this as B. So now we have a linked list with two nodes, and we have given names. The first one we are naming it as A, and the next one is B. And so our node A is containing data value 10. Let's say the address it is having here is, for simplicity I am just saying that it is pointing to B, and or B it may have, let's say, like a value of 5 here, and it is not pointing to anywhere. So that's why it is actually pointing to null, or basically it is not pointing anywhere. So let's not waste time and code this in editor. So let's name it as singly linked list, because we are, so linked list can be of two types. I'll just explain you. So here we have two parts in the node. So one is the data part, another is the address part. So even there is one more category of linked list where you have three parts. So basically you have one part in the middle part where you are storing your data, in the left part something like this. So it has three parts. So in the middle part, you are storing your data. In the left part, you are storing the address of the previous node. So this contains address, and the right node also contains address. So, but we are not going to do the insertion into the double linked list. We will start with the single linked list. So as you see in our linked list, we have to represent our data structure in a kind of node. So you can call it anything, but for simplicity, I will call it as node. So let's create an inner class node here. So the single linked list, it has two parts. One is the data. So we created a data variable, and the second part is the address part. So that's why we created the, or you can call it anything. Let's call it the next. So now let's create a method which will do the insertion into the node. This insert method, let's take the input as data because you need to insert some value to the node. Now if you see, we can have two scenarios: either we don't have a linked list or we already have a linked list. To represent that, let's create a node here, and let's call that a head as head, because this head will actually point to the initial block here. So this we can call as the head, because we are starting from here. We can call this as head. So the first thing that we need to check, if we are trying to insert, if the head is null, because if the head is null, then you need to create a head first. So then head equal to new node, and you pass the data here. So this is the case. Okay, let's create the constructor. So if we don't have anything, then we create a new node and assign that to head. But if we already have something in the head, that is if our linked list is not null, so in that case, what we need to do, so we need to find out the current pointer, and then we need to insert the data. So it is like, if we don't have anything, we created head. But let's say we already have two nodes. So in that case, what we do is we create a new node, and let's call it as C. So we and so now our B will point to C. So earlier it was pointing to null. So now instead it will point to C. So just we need to give this next node link to our newly created node. Okay, so let's code that. But to find out what is the latest node, so what we need to do is we have two options. First thing is, every time we insert a node, so we start from head, we go to the next node, we go to the next node till we find there is no node. So in this case, like, we go to node head, so we find that the next node is B. So sorry, we check that head is not null. Fine. So we went to head dot next, that is the node B, and we checked that there is like B exists, and again we checked for the B dot next, and in this case what we found was initially B dot next is null. So that's where we will be able to know that we need to create a node now and assign the B dot next to that newly created node. But this will create lot of, like, this will waste a lot of um, um, what to say, so because every time you are iterating and trying to find the next node, so this will be a wastage of time. So instead what we can do is we can have one more pointer. We can call that as the tail pointer. So it will always point to the latest node. So that means what will happen when we are creating this new node. So now our tail will point to head. So that's how next time when I want to insert a new node, so I don't have to iterate from the beginning, from the head to the last. Rather, I can directly know, I know that what is my last node. So we will just uh, code it, and we'll be able to find out what exactly I'm trying to explain you. So else what we will do, so we will tail dot next equal to new node data. So now let's have a main method, try to execute our code. Okay, so we added two elements. Now the next thing that we need to do is to print it so that you can see that actually our elements got added. So we need to write a method to print the elements. So what we're doing, so I created a new pointer which will actually point to our head node, and I will increment till there is no element. So I will iterate till there is till the current will point to null. So let's run and see. Okay, I need to increment here because else it will run in an infinite loop. So every time I print, sorry. So every time I print a single node, then I need to increment my current position to the next node. So it is like, so initially I am at the head node. I printed the data part. Then my pointer will point to the next node. Again, I print the data part. My pointer will point to the next node till there is no node. So as you can see, we have our output 5, 10, and 6. So I hope you have learned how to insert into single linked list. So thanks for watching, and please do subscribe to my channel so that I'll be happy to create more contents for you. And if you have any doubts, you can comment in the comment section. I will try to resolve it, or I will try to create a new video to help you solve your query. So thanks a lot. See you in the next video.